Hey guys, it's Adam from Premium Poker Tools, and today I'd like to talk about how to calculate expected value. And I'm going to talk about poker in particular, like how to calculate expected value. And I'm going to say in poker inside of parentheses because the way to calculate expected value isn't specific to poker. But obviously, here we're talking about poker, so I'm going to use a couple examples with poker. But I think it's important to understand that the general idea behind calculating expected value isn't something that's specific to poker. So let's start with an example of trying to calculate the expected value of 3-bet bluffing. So the way to calculate the expected value is step one, we're gonna draw a tree of all possible outcomes. Of all possible outcomes. And I'll show you what I mean by that. So let's say that we're 3-bet bluffing. Let's say that our opponent opens from middle position and we're in the cutoff and we 3-bet as a bluff. So what are the possible outcomes that can happen at this point? So, one option is that they call, another option is that they fold, and then another option is that they raise. And really, there's various sizes that they can raise to. So they could raise half pot, full pot, 3/4, an overbet, whatever. But here, we're going to try to simplify things, and let's just assume that our opponent is either going to call or fold. So let's say that they can either call, they can either call or they can fold. So call or fold. Okay, so once they fold, that branch is done with. But what happens after they call? So you can break it down in different ways. The way that I'm going to break it down is into 3 possibilities. I'm going to say that we can either smash the flop. So like if we have, I don't know, pocket 3s or something and we hit a set, that's like smashing the flop. I'm going to say that the flop can be good. So, if the flop is like 10-10-4, that's a flop that we can c-bet pretty profitably. So good meaning that we have a profitable c-bet bluff. And then finally, I'm going to say the flop can be bad. So if it's like ace, jack, 9 with like 2 hearts or something, that's a flop that we're going to get called pretty frequently. So I'm going to say that that's a bad flop for us and we're just going to give up. So let's kind of, once we smash the flop, let's kind of end the branching process there. And same with if it's a bad flop, let's assume that we just check fold and lose the hand. Let's just assume we don't have any showdown value. But if we have a good flop, we're going to c-bet. And after that, there's 2 things that can happen. We can get called, or we can get a fold. And like before, there's really a third possibility of getting raised, and a fourth possibility, raised to half pot, to full pot, to 3/4. There's various sizes, so we could draw a million branches off of this. But we're not going to do that. We're going to keep it simple and just assume that there's 2 branches. And obviously, this simplification is going to, mean that our output isn't going to be perfect. So we're not going to have, the most accurate possible output or expected value, but that's kind of a trade-off that we make by keeping things more simple. So this is what we've got. We have these are the possible outcomes after we 3-bet bluff. So let's oh, I zoomed in or I zoomed out or something. So anyway, here's step one. We drew a tree of all the possible outcomes. So now let's move on to step two. And I'm gonna do step two in a blue color. Step two is to write in the probabilities. Probabilities. I'm going to underline that. That's kind of the key word here. The probability is, let's just say, for each branch. For each branch. And I'll show you what I mean by that. So we're back to this tree. And now what we have to do is we have to say how likely is each branch to happen. So you can think of each circle or each node as like a decision point where there's various possibilities. So we're going to want to say how likely each possibility is. So initially, let's say they open and we 3-bet. How likely is it that they call? And I'm going to say that there's a 70% chance of getting called, which means that there's a 30% chance of getting an immediate fold. Okay, so now we reach this decision point. So now there's 3 possible outcomes. We smash, we get a good flop, or we get a bad flop. So now we have to ask ourselves, how likely is it that each of these 3 things happens? So I'm going to say that there's a 10% chance that we smash the flop, assuming, let's just say we have pocket 3s. Let's say that there's a 60% chance that we get a good flop. And let's say that there's a 30% chance that we get a bad flop. And remember, by good, I mean a flop that we can c-bet profitably, and a bad flop is one where we just check fold and we lose the hand. Okay, so now we got our 3-bet got called, and we have a good flop, and we decided to c-bet. So now, what are the chances that they call our c-bet, and what are the chances that they fold? And I'm going to say that we're a little bit fortunate, and they're folding 60% of the time to our c-bet. And that's not really a, crazy number. A lot of people fold 50% of the time on average. But here, we have a flop that's particularly good for c-betting, so it's more likely that they missed. So I'm going to say 60%. Yeah. And that means that there's a 40% chance that they call. Okay, so that was step 2. So we drew the tree of all the possible outcomes. Then we wrote in the probabilities for each branch. And now we're going to move on to step 3, and I'm going to do that in green. So now let's say that step 3 is to write in the outcome, or I guess we can say the result for each leaf. And again, I'll show you what I mean by that. So let's say, like we 3-bet pre-flop and get called. This isn't a leaf node because, the hand still kind of progresses from this point. But if we 3-bet and get an immediate fold, the hand is over. So this is kind of considered a leaf node. Just like on a tree, you you have branches. If this branch branches off again, this isn't a leaf. But if this is the end here, this doesn't branch off more, this is kind of a leaf. So they take that term from kind of a real tree. So on a real tree, these three are the leaves. So I mean the same thing when I'm talking about our outcome tree. So this right here is a leaf, this is a leaf, this is a leaf, this is a leaf, and this is a leaf. And this one, and this one are not leaves. Okay, so now let's talk about what we're gonna write down here. So let's say that we're playing, 1-2. So the blinds are in, so the pot starts off at $3. And let's say our opponent raises to 6. So they put 6 in. And let's say that we 3-bet to 20. If we get an immediate fold, we're going to win the $3 that were initially in the pot, plus the 6 that they put in. So here, we're going to write in $9. That's how much that we're going to win if, we get an immediate fold. Okay, so now let's move on to another leaf. So let's say that we get called, and then we smash the flop. So here's how I'm going to look at that. I'm just going to erase this. Okay. So here, $3 were in the blinds, we 3-bet to 20, and they called. I like to draw these kind of diagrams. So now the turn, let's just ignore rake for a second. So the turn, there's 43 in the pot. And let's say we smash the flop. So let's just assume that we c-bet to 30 and get called. So then the turn is going to be 60 and 43, 103. And let's say that we get another street of value on the turn. Let's say for $75. So, and let's just say that we don't get our third street of value. And obviously, sometimes we're going to get 1, sometimes 2, sometimes 3, sometimes 0 streets. So really what we should put down here is an average. But for now, I'm just going to use, 2 streets of value as kind of a rough estimate of how much value we're going to get when we smash the flop. So let's see, how much did we win in this scenario? So first we won the $3 in the blinds. Then we won 20 from our opponent on pre-flop. And I'm going to get a calculator out actually. So we won this $3 in the blinds. Then we won another 20 from our opponent pre-flop. Then we're going to win another 30 on the flop. And then finally another 75 on the turn. So in this scenario, we ended up winning $128. So that's what I'm going to write in. Oops. Over here. In this leaf node, we ended up winning $128. Okay, so now let's continue the process. So we get called, we have a good flop, and we c-bet, and then we get called. So here, once we get called, we're going to assume that we just lose the hand. So how much did we lose in this scenario? So we put in $20 pre-flop, so we lose that. And then we put in another $30 on the flop, and we lost that. So here, we're going to end up losing $50. Okay. So now let's go to the next one. So we get called, we get a good flop, and we c-bet, and then we get a fold. So how much are we going to win in that scenario? Well, we're going to win the initial blinds. We're going to win the $20 that they put in pre-flop, and then they fold on the flop, so we're just going to win this $23. Okay, so now we're on the last one. So we get called pre-flop, and then we have a bad flop. So now we just give up and lose. So how much are we losing in this scenario? Well, now we didn't bet the flop, so we're only losing the $20 that we put in pre-flop. So here we lose $20. And this was step 3. So we drew our tree of all the possible outcomes. We wrote in the probabilities for each branch. Then we wrote what the outcome/result is for each leaf. And now let's move on to step 4. I'm gonna make this in like a red color. So step 4, I'm just gonna call this step math. I mean, everything we're doing here is math, but you'll see what I mean. So now with all this information, now we can really start to compute what the expected value is. And what we want to do is we want to start off, we want to look at what are all the possible outcomes, kind of. So I'll show you what I mean. One outcome is that we just get a fold right away. So let's write that down. Another outcome is that we call and then we smash the flop. So let's write call and then smash. Another outcome is we call and get a good flop and then get called. So let's write down call, good, call. Another, we get call, good, fold. And then finally, call and then hit a bad flop. So these are kind of the 5 possible outcomes, and you can see they kind of correspond to the 5 leaf nodes. So now we're going to do some math. So what we're going to do is we're going to ask ourselves, where should I write this? Let's say 1, we're going to ask what's the probability of reaching, of having this outcome. And then 2, what's the result, let's say. So I'll show you what I mean. So the probability of getting a fold right away is 30%. So we write 30%. Let's just do it in this form. And then the result is that we gain $9. So this one was easy because the probability was just one number. But for the rest of them, we're going to have to do, multiply the probabilities. So what's the probability of getting a call and then smashing the flop? We're going to have to multiply 0.7 times 0.1. So 0.7 times 0.1, that's the probability that we reach this point. So that's probability. And now we're going to write down the result. So the result is $128. Okay, so now we're going to do the same thing. So what's the probability that we get called? We hit a good flop, and then we get called again. So to get that probability, we multiply all 3 of these numbers. So we're going to multiply 0.7 times 0.6 times 0.4. So that's the probability. And now we're going to multiply by the result of negative 50. Okay, so now to speed things up, call, good, folds, 70, 60, 60. And the outcome there is $23. And then call bad, that's 70 times 30. and here we lose $20. Okay, so now to continue this math step, I guess we can say, and I'm not going to write it down. So now we're going to calculate each of these, and then we're going to add them all up. So let's get out the calculator. So for the first one, 0.3 times 9. 0.3 times 9, 2.7. So here we win $2.7. Okay, so now 0.7 times 0.1 times 128. 0.7 times 0.1 times 128, 8.96. So the value kind of this branch is 8.96. All right, so now the third one, 0.7 times 0.6 times 0.4. 0.7 times 0.6 times 0.4. And then times negative 50, I'll just do times 50. So here it's negative 8.4. I'll put a 0. Okay, so now the fourth one, 0.7 times 0.6 times 0.6. Times 23. 5.796, I'll just do 5.8. Now finally, we have 0.7 times 0.3 times negative 20, I'll do times 20. So negative 4.2. Okay, so finally, now all we have to do is add all of this up. So we have 2.7 plus 8.96 minus 8.4 plus 5.8 minus 4.2. So finally, we get our expected value of $4.86. 86. That's our result. So again, so here what we're doing is we're 3-bet bluffing, and then we're following up with a C-bet on good boards. So the expected value of taking this line is about $4.86. So because we're playing 1-2, it's about 2.5 big blinds. So that's a pretty solid result. So again, let's just go back to the steps. To figure out the expected value, first we drew a tree of all the possible outcomes, and I'm going to kind of zoom out so you can see everything at the same time. So we drew the tree of all the possible outcomes. Then we wrote down the probability for each branch. What's the probability that we get called, that we smash the flop, that we have a bad flop. Then third, we wrote what the outcome is for each of the leaf nodes. And then fourth, we did a little bit of math. We wrote down what the 5 possibilities are. Then we figured out kind of what the value is for each of these paths down the tree. And then we added them all up, and by doing that, we got a result of 4.86. So that is how we calculate the expected value of 3-bet bluffing. So with this knowledge, you can kind of take this and do your own analyses. So like if you wanted to incorporate the possibility of getting a raise, like let's say you want to see what happens if they raise half pot sometimes and they raise full pot. other times, you can do that. Okay, so now I gave you an example of how we calculated expected value in poker, but I really want to make you understand that the way to calculate expected value is the same for anything. It's not specific to poker. So to use kind of a fun example, let's think about like the expected value of going on a date. And my reason for doing this isn't to convince anyone to go on a date. I have a girlfriend, but I want to show you that the way to calculate expected value is the same for any context. It's not specific to poker. So in the same sense that probability is like a math thing, it's not a poker thing, expected value is also a math thing. It's not a poker thing. So, let's say you go on a date. What are the possible outcomes that can happen? Let's just say that it can either go good or bad. It can go good or it can go bad. Okay, so if it goes bad, let's assume that you don't call them back, they don't call you back, and that's it. And let's just say if it goes good, you could end up falling in love with each other, or you could just have a fun time and you don't see each other again. So, let's actually go through it. Let's have some fun and see what the expected value we get is. So how likely is it that the date goes good? Let's say it's 30%. So 70% of the time it's bad. It's kind of funny. It's the same 30-70. All right, so once the date goes good, what are the chances that you fall in love and, that's your soulmate? What are the chances? That's a pretty good question. Let's say it's 0.1%. 1 in 1,000. And then the rest of the time you just had a fun time. So that's 99.9. So again, we just did steps 1 and 2. So now let's write kind of what the outcome is. So a lot of people think that you can only do these kinds of analyses for like objective things like money or whatever else, but that's not really true. You can kind of try to quantify what the outcome is. So let's just talk about it in happiness points. So let's say that if it's a bad date, you lose 10 happiness points. And let's say if it's a good date and you have fun, let's say that you gain 20 happiness points. And economists call this utility, so let's write utility. Or utilons. So now we get to the interesting point of what's the value of falling in love. If we said 20 for having a fun time, how much more valuable is it to fall in love than to have a fun time? It's probably more than 100 times, maybe 1,000 times more valuable. I don't know. Let's say it's 1,000 times more valuable. So 20, 10, 100, 1,000. So plus 20,000 utilons. And now for fun, let's just do the math. So here, let's just kind of write it in here. We have 0.3 times 0.001 times 20,000, 20K. Here we have 0.3 times 0.999 times 20. And here we have 0.7 times -10. So let's see what each of these adds up to. 0.3 times 0.001 times 20,000. So the value of this is 6. So 0.3 times 0.999 times 20, 5.994. 5.994. Now the last one, 0.7 times negative 10, so it's equal to negative 7. And then we add this all up, and let's just say 6 and 6 is 12, minus 7, so, whoops, not dollars, it's, so the value of going on a date is about 5 Eudolons, according to these assumptions. So again, I'm not trying to convince anyone to go on a date. I'm showing you that the way to calculate expected value is not specific to poker. Even if you're trying to figure out the expected value of going on a date, what you do, you take the same steps. You draw a tree of all the possible outcomes. Then you write in the probabilities for each branch. Then you write in what the outcome is. And sometimes the outcome is money, sometimes it's Eudolons, sometimes it's, I don't know, like oil or whatever you're calculating. And then finally, you do a little bit of math, and you add up the numbers for each branch, and you get your output. So you take this process, and you can calculate the expected value of anything. And just to give you one more poker example, let's look at, let's say, bluffing the turn. Bluffing the turn. So if you bluff the turn, let's just say you can get called or you can get a fold. A call or a fold. Let's say you get called. Let's say that you hit an out. If you hit your flush draw, let's say you can get a scare card, and let's say that you just miss. And let's say once you miss, you give up. You hit an out, we kind of ended there. You get a scare card, and you're going to bluff again. And once you bluff again, you can get called or get fold. So this tree ended up being the same as the 3-bet bluffing tree we did, basically. But yeah, you take the same process for any situation in poker. You just draw this tree and you figure out what the possible outcomes are. And then you do steps 2, 3, and 4. So hopefully understanding this process will allow you to run your own EV calculations and understand how expected value works. And so to kind of end the video, you're probably thinking this is a lot of math. I don't really want to sit here and do this. So I'm working on something called Premium Poker Tools, and I built this tool to help you figure out the expected value of bluffing the turn. So what you do is you kind of, there's all these variables. You can say how many outs you have, how much extra money you make when you hit your out, how many scare cards there are, all these variables. So instead of playing around with the numbers yourself, putting in the probabilities and the outcomes and all that, you can use my tool, and it's going to tell you what the expected value is for bluffing the turn. And it's going to tell you the break-even percentage is when the EV of bluffing is equal to the EV of checking. And I plan on making more of these tools for different situations, so you don't have to sit here and run the numbers yourself. But, of course, you're welcome to run the numbers yourself. I encourage you to do that as well. So to wrap things up, if you have any questions or if this doesn't make sense or any feedback or anything, please shoot me an email. It's right here at the top of my app, azerner3@gmail.com. I'd be happy to explain things more. If you want to Skype, I'd be happy to walk you through it, whatever you want to do. And again, I'm working on premiumpokertools.com. I'll put it in here. So please check it out and let me know what you think of that as well. All right, guys, have a good one.